So we're going to actually talk a little bit about rate of change, average rate of change, and then we'll kind of go on to something different, but then we'll come back to it. So average rate of change is very similar to rate of change of a line. So if you recall, when you're graphing linear functions, rate of change just basically meant slope. It meant rise over run. It's kind of the same idea when you're graphing parabolas, only let's say I have a parabola that looks like this. Okay, so on one side you can see the slope, if you will, appears to be decreasing, and then it appears to be increasing. So I really can't say what's the rate of change of the parabola in regards to what's the slope, because it changes depending on where you're looking. So a lot of times what they do is they'll give you an interval. So they'll say, what is the rate of change between here and here? And what they want you to do is draw a line connecting those 2 points, and they want to know the slope of that line that you drew. So you can still calculate it the same way that you would calculate slope. It's just we refer to it as average rate of change because it's the average amount of decrease or increase on a certain portion of that graph. So like I said, we'll come back to that, but I always like to just kind of introduce that first and kind of get that in the back of your head. All right, so we're going to review here writing vertex form from standard form. So if you recall, vertex form looks like this. F of x equals a times x minus h squared plus k. And your job is to fill in a, which is given to you when something's in standard form. So in this case, a is -3. Oops, here we go. Your job is also to figure out what h is. So if you recall, the formula for h is opposite of b over 2a. So in this case, opposite of b would be -4. 2a would get you -6. And then I would reduce that to 2/3. So once you know a and you know your h, now you're ready to go get your k. So we take our h value and we substitute it in for x. So notice it says x squared. I like to square my h right off the bat. So if I do 2/3 squared in my head, I get 4/9. I also like to do 4 times 2/3 in my head. So I know that the middle term is going to be 8/3 plus 2. I like to cross reduce when I can. So now I get -4/3 plus 8/3. And I'm going to change 2 and 6/3. That way I have all common denominators. So it looks like I'm going to get 10/3 for my k value. So then my answer is f of x equals a parenthesis x minus h squared plus k. So again, that's going from standard to vertex form, and now we're going to go from vertex form to standard form. So the first thing I want to do is put a squared here, because that should be there. So there's a little typo there. And then if I was going to do that, the first thing I would do is FOIL this out. So if I would get an x squared, I would get -3x minus 3x, which makes -6x, and I get +9. Then I would distribute, and my answer 1/2 x squared minus 3x, half of 9 is 4.5 plus 10. So it looks like my final answer is 1/2 x squared minus 3x plus 14.5. So what we're going to do today is I'm going to give you a vertex, and I'm going to give you a point that's on the parabola, and you can actually write the equation of the parabola from that information. So you'll be given an h, you'll be given a k, an x, and a y. So we're going to take those values and we're going to plug it into our vertex form. When we do that, you're going to see that you have an a that you need to solve for, so you solve for your a, and then you rewrite the answer with h, k, and a in it. And this will make sense once we actually go through a problem. All right, so number 1, if you can see, I've provided you with the vertex. So the first thing I would do is go ahead and label H as 1 and K as 25. And then it does not matter which other ordered pair you use. You can use the 6, 0 or the negative 4, 0. I would personally use positive numbers. That's just my preference. In that case, X is 6, and instead of writing f of x, I like to write, or excuse me, instead of writing y, I like to write f of x for this. I get 0. All right. So once you have that information, you can go ahead and plug that into vertex form. So the form says you do f of x equals a, parenthesis x, which is 6, minus h squared, plus k. So a little bit of cleaning up here. 6 minus 1 is 5. 5 squared is 25. So I actually like to write that as 25a. And if I were to solve that equation, I'll find out that a is negative 1. So when I go to write my answer, I want to have f of x back in it. You can either write negative or negative 1. It's the same thing. Parentheses, so a times, we put x back in, but we replace h and k. So that's my equation in vertex form. We're going to do it again because sometimes it takes a little extra practice, especially when there's fractions involved. So I know that h is going to be negative 3.5. You're going to see me a lot of times, it's just a preference thing. I like to rewrite my fractions as improper fractions. I just think they're easier to compute that way, so I'm actually going to change 3.5 to 7 halves. Then I can go ahead and say k is negative 1/4, and then I can pick which of these I want to be x and y. So I guess I'll just go with negative 3 for x, and I'll go with 0 for y. So I got all 4 of my values labeled, and now I plug them into my vertex form. So we have f of x equals a, parenthesis, we have x, minus h would actually become plus 7 halves, so I'll go ahead and write plus k. Now if I want to go ahead and do negative 3 plus 7 halves, I actually like to think of it as negative 6 halves plus 7 halves. And negative 6 plus 7 is 1, so I get 1/2 squared, which is really just 1/4. So if I were to solve that problem, I find out that a is just 1. So when I go to write my answer, I'm going to write f of x equals, now it's optional, you do not have to write 1, you can, but you can actually just go ahead and write x minus h squared plus k. So that's kind of the idea. So in your next couple examples, you can see you have a picture. You only have 1 point and a vertex to work with, so everyone has to use the same numbers. And then you also have like more of a word problem, but it still tells you the point and the vertex. So what I'd like you to do is go through and try these ones on your own, and while you're doing that, I'll go ahead and post the answer key. You can pause the video and then unpause it when you're ready to check your answers. Alright, so you can check your answers here. You should have got A is 2 for number 1, and then A is negative 1/2 for number 2. And then you present our answers as such. And I just want to point out that when you look at number 2 here, both of these would be considered the same answer. So either of those would be fine, since x minus 0 is just itself. Technically, you don't need to have the minus 0 there. And then hopefully we labeled these points correctly, put them in their correct spots, did our math correctly. We should have got 2 for A, and number 4 we should have got 1/2 for A, and then the rest we just substitute into the formula. Alright, so in our next video we'll go ahead and we'll talk about, we'll do a computation of rate of change. We'll talk a little bit about differences and second differences, and how those can kind of play a role in your knowledge of a graph. And then we'll kind of wrap up this section of our notes.